GATE 2015 Civil Engineering Set 1 question number 38. An earth embankment is to be constructed with compacted cohesionless soil. The volume of the embankment is 5000 per meter cube and the target dry unit weight is 16.2 kilonewton per meter cube. Three nearby sites have been identified from where the required soil can be transported to the construction site. The void ratios E of different sites are shown in the figure. Assume the specific gravity of soil to be 2.7 for all three sites. If the cost of transportation per kilometer is twice the cost of excavation per meter cube of bore pit, which site would you choose as the most economic solution? And use unit weight of water as 10 kilonewton per meter cube. Options are site X, option B is site Y, option C is site Z, and option D is any of these. Reference to the relevant NPTEL courses or video has been cited. Now coming to the useful data, in the problem of mixing of soil, excavation or transportation, we either equate weight of the soil or volume of the soil. Let's suppose if you are excavating from a particular site, the weight of soil of the excavation site will be equal to the weight of soil of the embankment site where we are transporting the soil. And same like that, the volume of soil of the embankment site will be equal to the volume of soil of the excavation site. And from the three-phase diagram, we know this equation, which is volume of soil will be equals to the total volume of soil divided by 1 plus E. And if you are solving it for excavation site, here E will be is the void ratio that will be of excavation site. Same like that, we can also write volume of soil of the embankment site will be equal to the total volume of soil divided by 1 plus E, and here the void ratio will be of the embankment site. Now coming to the video solution, the dry unit weight of the construction site is given as 16.2 kilonewton per meter cube. So we can write gamma D of the embankment site is 16.2 kilonewton per meter cube. As we know, the equation for dry unit weight is gamma D equals to Z into gamma W upon 1 plus E, where E is the void ratio of the construction site or embankment site and gamma W is the dry unit weight of water. Now if we put the values here, we can write gamma D is 16.2 and our specific gravity is given as 2.7 into unit weight of water is 10 and it is 1 plus E. So if we solve it, we will get void ratio of construction site as 0.67. Now from the equation part, we know that the volume of soil of excavation will be equal to the volume of soil of the embankment site. We know, if you solve it for site X, we can write as total volume of soil divided by 1 plus E, that is of site X, will be equal to the volume of total volume of soil divided by 1 plus E, that is of embankment or our construction site. Now we can write total volume of soil of site X divided by 1 plus E of site X will be equals to total volume is 5000 and the void ratio of the construction site is 0.67. So we can write it as 1 plus 0.67. So let's say this is our equation number 1. Like that, we can solve it for site X, site Y and site Z. So let's first we solve it for site X, because in the question the different void ratio for different sites are given. So for site X, the void ratio E is 0.6. Now if you put the value, we will get the total volume of soil at site X, that will be equals to 5000 divided by 1 plus 0.67 into 1 plus void ratio of site X, that is 0.6. Now if you solve this part, this is 2994 into 1.6, so that becomes 4790.42 meter cube. So that is the total volume of soil at site X. Now like that, we can solve for site Y. For site Y, the void ratio is 0.7. So the total volume of soil from site Y will be equals to 2994 into 1 plus 0.7. Now if we solve it, we will get 5089.8 meter cube. Like that, we can solve it for site Z, and for the void ratio of site Z is E is 0.64 for site Z. Now the total volume of soil from site Z will be equals to 2994 into 1 plus 0.64. Now if you solve it, we will get 4910.16 meter cube. As you know, in the question we have to find the most economical site. So for that, we have to do the cost calculation, means we have to find out the total excavation and transportation cost at a particular site. So now if you do the cost calculation, let's say we assume the excavation cost for any site is 1 rupees. Excavation cost for any site is 1 rupees, and let's say the transportation cost is coming as 2 rupees. Cost is coming as 2 rupees. Now let's say if you solve it for site X, the total cost will be equal to the total volume of soil, that is 4790.42 into into 1, that will be the excavation cost, and the distance from site to the embankment site is given as 140 kilometer into 2 rupees. Now if you solve it, we will get 5070.42 rupees. So that will be the total cost at site X. Like that we can solve it for site Y. For site Y, the total volume was 5089.8 into 1 plus the total distance is 80 into 2. Now if you solve it, we will get 5249.8 rupees. And for site Z, we will get the total volume of soil was 4910.6 into 1 plus the total distance is 100, so that will be 5110.6 rupees. Now if you see the cost which is coming at all three sites, like for site X is 5070, for site Y it is 5249, and for site Z it is 5110. So comparing all these three sites, we can see that the site X is the most economical site, so we can say that site X is the right answer. So now for this question, site X will be the right answer because the cost coming at site X is less than the other three sites. So reference to the relevant NPTEL courses or video has been cited.